guys, today we're going to be going over a quick review of essentially how to read the periodic table. So what all the different numbers mean and how to use them. Okay, so this lesson is titled Explaining the Periodic Table. And what we're going to be going over is what atomic mass, atomic number, and mass number are, as well as where to find them on the periodic table. And then also how to determine the number of protons, the number of neutrons, and probably the number of electrons as well, based on those numbers. So the atomic number is the number of protons found in the nucleus of an atom. It's usually found somewhere in the top of the box that an element is located in on the periodic table. And this is what makes each atom unique. It's actually how we identify what type of element an atom is. No two elements have the same atomic number or the same number of protons. So if I give you the atomic number of something, you can definitely tell me which element I'm referring to. So for example, hydrogen has an atomic number of 1. That tells us that it has 1 proton. If we were told that something has the atomic number of 13, you would be able to tell me that it has 13 protons and that it's aluminum. The only way that we could change the number of protons that an atom has is through a nuclear reaction. So there's no way through physical or chemical reactions that you can alter the nucleus of an atom, which is where the protons and neutrons are. So nuclear reactions are the only way to change the nucleus. And there's 2 different types of nuclear reactions. There is fusion and fission. Fusion is when you take the nuclei of 2 different atoms and combine them to form a new nucleus that will have the number of protons of those 2 that you just combined. So for example, if you take 2 hydrogen atoms and combine them, each one of our hydrogen atoms has 1 proton. If we combine those, we now have a nucleus with 2 protons, which is helium. So that's how we make helium. On the other hand, fission is when we take a nuclei and we split it into multiple new nuclei. Usually you do that by firing a neutron at the nucleus and breaking it apart. So that's what this example over here is showing us. Okay, the mass number is essentially the mass of an atom, which is made up of the mass of its protons and neutrons, which is just the mass of the nucleus. Electrons have a mass of approximately 0, so we don't include them at all in the mass number. Both protons and neutrons have a mass of 1 unit, so they're roughly the same in mass, which means that if we have the mass number and the atomic number, we can calculate the number of neutrons. So if, for example, you were told the atomic number was 3 and the mass number is 7, the number of protons is just the atomic number, so we would have 3 protons. The mass number is the protons plus the neutrons. So if I have a mass number of 7 and I know 3 of those 7 are protons, then the remaining 4 must be neutrons. So the number of neutrons is just the mass number minus the atomic number. So try the question number 2 on your own. So pause here and then come back and see if you got the right answer. Okay, so with a mass number of 12, and we're told that there are 7 neutrons, that means 7 of the 12 are neutrons. The remaining 5 must be protons. So we have 5 protons, and then based on that, we can figure out what element it is. So all that you would do is you would take your periodic table, you would see which one of these has a 5 at the top of the box, so an atomic number of 5, and that's the element. So in this case, it would be boron. Isotopes are any atoms of the same element that have different numbers of neutrons. So the reason that we can only use the atomic number or the number of protons to identify an atom is because the number of electrons and the number of neutrons can change without changing the element. The number of protons cannot change without changing the element. So we identify the element based on the number of protons, which is the atomic number. We cannot use anything else to identify the element. So there are these things called isotopes, which are atoms of the same element, but with different numbers of neutrons. And as soon as we change the number of neutrons, we also change the mass of that atom. So isotopes will have different masses, different mass numbers, as well as different numbers of neutrons. And we use the mass number to distinguish between isotopes. So for example, carbon is an element. Carbon will always have 6 protons. However, you can have carbon 12, which has 6 neutrons and 6 protons, or you can have carbon 14, which has 8 neutrons and 6 protons. And we differentiate them because carbon 12 has an atomic mass of 12, carbon 14 has an atomic mass of 14. But they both have an atomic number of 6 because they will always have 6 protons. Okay, the atomic mass is slightly different than the mass number. The atomic mass can be found on your periodic table. It is the number at the bottom of the little box that each element is in. And it is a proportional average of the masses of the different isotopes of an element that are found in nature. So for example, carbon has an atomic mass of 12.0107, which means that the vast majority of carbon atoms that exist in nature have a mass of 12, but a couple of them have that mass of 14 we were just talking about, which is what makes the atomic mass not just an even 12, but a 12.01. You'll see some that are less even than that. So for example, if we look at chlorine, it has an atomic mass of 35.45, which means that almost half of chlorines have an atomic mass of 35, and the other half have an atomic mass of 36. So we're kind of averaging them out. Okay, that's not important. So on the periodic table, you're given the atomic number at the top, the atomic mass at the bottom. You might be wondering, where's the mass number? And to find the mass number, all we do is take the atomic mass and round it to the nearest whole number. And this is something called standard notation. It's how we represent an atom or an element. So the symbol in the middle just represents the element. That's the same symbols that you will see on your periodic table. So C would be carbon, and then the atomic number goes on the bottom, the mass number goes on the top, which is backwards from how we would see it on the periodic table. So just keep that in mind. The one other thing I want to talk about is how to find the number of electrons. We haven't touched on that yet. So to find the number of electrons, all you do is if your atom is neutral, means it hasn't lost or gained any electrons, the number of electrons will be equal to the number of protons, which means it's also equal to your atomic number. But as I've said before, the number of electrons can change and often does. As soon as you change the number of electrons, you change the charge of the atom, which is how we get ions, which we'll talk about later. Because electrons are negative, if you lose an electron, you become less negative, so you get a positive charge. If you gain an electron, you become more negative, so you get a negative charge. And we'll talk more about that later, For now, just know that the number of electrons can and will change, which also changes the charge. If the charge is 0, so the atom is neutral, the number of electrons will equal the number of protons. Okay, that's it for today. Let me know if you have any questions.